Okay, now let's move on to the next topic of what you call the anti-derivative action. And we know that, as it appears from name, that this should be kind of a opposite process of doing the derivative. We know that if my function is x squared, the derivative is 2x actually. Okay? So I'll define in a moment that, what do you mean by antiderivative? Consider the situation that, I know that if I know the position of a particle at any time t, I can compute the velocity of the particle actually. How can I compute the velocity of the particle? Just to differentiate this with respect to t, okay? So differentiate the position of the particle with respect to time, and this would be the velocity of the particle actually. So I know s of t, and we can find the velocity of the particle. Here is the interesting question. If you know the velocity of the particle, can we find the position of the particle from the velocity? So we have to go the opposite way. So if you know the position, you can compute what do you call the velocity. But now I want to say that, okay, I know this is the velocity of the particle. I want to know what is the position of the particle at this time actually, or at some future time. And I can play the same game with acceleration. So we know that if we know the velocity of the particle, then we can compute the acceleration of the particle actually. The question is, can I go backward actually? So in other words, if you tell me that this is what is the acceleration of the particle, can we make a prediction about the velocity of the particle actually? So we have to, so from velocity to acceleration I need to derivate actually. But from acceleration to velocity we need to do the antiderivative actually. Okay? The opposite of what we have been doing actually. So we will now focus on the thing that, okay, if you give me acceleration, can I find what do you call the velocity? Okay, can I find the velocity? So in other words, for example, if you have been a given function which is f of x, and you computed its derivative, which is say f of x, capital F of x, where the capital F of x is the derivative of f of x. Okay? And I want to know from this f of x, can I get the function f of x actually? So if the derivative has been given to me, a rate has been given to me, can I, what do you call, find the f of x? Okay. So for example, you know the population of some bacteria or some viruses at any time t, then we know that I can compute its derivative, okay, and I can know that what is the rate at which the population of the bacteria is increasing. But what if I want to go other way around? In other words, I have been given, what do you call, the rate at which the population is increasing, and I want to make a prediction about the population of the bacteria or the viruses at that time actually. So what do we like to do? We will like to go backward actually. So let me define what do you mean by an antiderivative. So we know the derivative, so what should be the antiderivative naturally? So a function, capital F of x, I'm going to say that it is called antiderivative. Okay, so it's antiderivative of f of x. Okay, if I differentiate the function f and I recover the function f of x actually. Okay? I recover the function f of x. Okay? So this is what that we would like to do now with the different type of functions. Let me start with a simple example. Okay? This is what is the definition of what you call antiderivative. The question is, if I give you a function, say f of x, which is say x squared, can you guess its antiderivative? In other words, what function I must write here so that when I differentiate this function, I must get x squared. I must get x squared. So what could be your guesses? So for example, one guess could be, the wild guess could be that take x cubed divided by 3 for example. So if you take x cubed divided by 3, I'm going to talk about the methods that how to find such antiderivatives. If you take for example x cubed divided by 3, the derivative of this is going to be x squared. Okay, so 3x squared, 3 will cancel out and you're going to get x squared. But here's another interesting thing. How about if I take x cubed upon 3 plus 1? What is the derivative of f of x, capital F of x? So the derivative of capital F of x is really, what do you call, the derivative of f of x is going to be what? This is going to be still x squared. So it's not x cubed upon 3, which is the antiderivative of x squared. It's x cubed upon 3 plus 1 also, which is the antiderivative of x squared. How about if I write, say, x cubed upon plus 3 minus 1? And I compute the derivative of capital F of x. So you're going to get what? Again, x squared actually. So x cubed upon 3 minus 1 is also an antiderivative of x squared. How about if I, for example, say I have x cubed upon 3 plus constant actually, plus a constant, where the constant is some constant c. So if you differentiate it, what are you going to get? 3x squared, 3 would cancel, x squared plus the derivative of the constant with respect to c, x is 0. So again you're going to get x squared. So the antiderivative of a given function is not just a one function, but it's a family of the function. So x cubed upon 3 plus 1, x cubed upon 3 plus 2, x cubed upon 3 plus minus 1 upon 2, x cubed upon 3 plus pi. All this family of the functions are the antiderivatives of what do you call x squared actually. Okay? So always, whenever you haven't given a function, its antiderivative is going to be some function plus constant c. Always. Okay? So for a given function, antiderivative is really some function f of x plus some constant. Okay? So this is what that really we have to find in all of these what do you call situations actually. So for example, if I give you, okay, so if I have sin x actually, I want to find a function. To that function, if I differentiate, I get, for example, sin x. So a wild guess could be cos x. Okay, a guess could be cos x. But what is the derivative of the cos x? The derivative of the cos x is minus sin x. But I want I want positive sin x. You know, plus sin x, not minus sin x. Okay, I want plus sin x. So what should I do with this cos x so that if I differentiate that, I should get, what do you call, minus sin x. So plus sin x. So let's put a minus cos x. Now if you take minus cos x and differentiate it, you're going to get a sin x. Okay, so this is what is really the antiderivative of sine x. But if you put a constant, this is also antiderivative of what do you call sine x. If you differentiate this, the derivative of the minus cos x is sine x plus the derivative of the constant is 0. So this means that minus cos x plus 1, minus cos x minus 1, all these are the antiderivatives of what do you call sine x. How about if I give you a function, say 1 over x? In other words, give me a function whose derivative is 1 over x actually. So what would be your guess? So I hope you guessed it correctly that it is going to be log x plus this arbitrary constant c actually, no matter what value of constant you choose. So log x plus c. So this is the family of the curves which is antiderivative of 1 over x, because if you differentiate it, you're going to get 1 over x actually. Okay? You're going to get 1 over x. How about if I give you, for example, instead of x squared, I give you say x cubed, and I say find the antiderivative of it actually. So I want for sure x power 4, okay, because x power 4 is a function. If I'm going to differentiate it, I'm going to get a cubic function. But what should be in front of, because if I derive it now x power 4, I'm going to get 4x cubed. But I just only want cube actually. So I have to get rid of this 4, which is in multiply. So I need to divide by 4 actually. Plus c. So this is really is the antiderivative of x cubed. How about if I give you a general power, x power n actually. Okay, n is any power except minus 1 obviously. Then what should be the value, what should be the antiderivative of it? So the antiderivative of it should be what? X power n plus 1, because if you take x power n plus 1 and derivate, you're going to get x power n. But there will be n plus 1 in the coefficient. But I don't want n plus 1 here. So what should I do? So let's divide this by n plus 1 plus c. So if I derive this x power n plus 1 divided by n plus 1 will be multiplied, which will be cancelled, and minus 1 would give you x power n. Okay? So in antiderivative, you have to kind of guess the function whose derivative is this function actually. Okay? Say for example, I want e power x. I want to find a function whose antiderivative is e power x. So what you're going to do? You're going to do e power x. Okay? I want a function whose derivative is cos x. What would be this function actually? You're going to say this function is really sine x. Okay? So that's what you have to do. So you have been given a function and you have been asked to find a function whose derivative is this function actually. Really the opposite of the derivative. Okay? Now you are not finding the derivative, but you are finding a function whose derivative is given actually. Okay? So this is what that you're going to do. And if I give you now, for example, we can talk about a lot of, and similarly you can extend this list actually. Okay, you can extend this list. You can extend this list actually. Okay. So if I want a function whose derivative is cf of x, then this function is going to be c capital F of x, where the capital F of x is a function whose derivative is f of x actually, plus c. Okay? I want a function which is sum of two functions actually, f of x plus g of x. Then you need to find two functions, capital F of x n capital G of x, their sum, such that the derivative of f of x is this small f of x, and derivative of this capital G of x is this small g of x. Okay. So it's also linear like the derivatives. How about if I give you, for example, secant square x? In other words, what is the function whose derivative is secant square? So you're going to say tangent x. What is the function whose derivative is 1 over 1 minus x squared? So you're going to say sine inverse x plus some constant and so on and so forth. So this is what really is going backward actually. Okay, going backward. So let's solve some problems based on this list. Okay. So first example is find G such that whose derivative is this 4 sine x plus 2x power 5 minus square root of x over x. Okay, so I want to find a G. I want to find the function whose derivative is given to me. So what should be the best way? The best way should be, okay, simplify it as much as possible to g prime of x, 4 sine x plus, okay, 2x power 5 over x minus x power 1 over 2 over x. So you're going to get 4 sine x plus 2x power 4 minus x power minus 1/2. Okay. So now let's do the antiderivative. What would be the gx? So what is the antiderivative of the sine x? In other words, what is the function whose derivative is sine x? So you're going to say minus cos x, minus cos x. So 4 would stay same. So 4 would stay same, and the derivative of antiderivative of sine x is minus cos x plus. What is the antiderivative of 2x power 4? So 2 would stay same. The antiderivative of x power 4. So apply this result. The antiderivative of x power n is x power n plus 1 divided by n plus 1. So this is going to be x power 5 upon 5. What would be the antiderivative of x power minus 1/2? So it's going to be, again apply the rule. Okay, this rule would not work when n is minus 1, obviously, because if n is minus 1 you are trouble. Denominator becomes 0. So it's going to be x power minus 1/2 plus 1 divided by minus 1/2 plus 1. This is what that you're going to get. So my g of x should be minus 4 cos x plus 2 upon 5 x power 5 minus, this is going to be x power 1 upon 2 divided by 1 upon 2, which will become 2 actually, and plus the constant c. So this is really is the, what do you call, the antiderivative of g prime of x actually. So in other words, the antiderivative is given. So I took g prime of x and I applied the process of antiderivative and I recovered the function g actually. So if you differentiate g, you're going to get this. So we are doing the opposite of what we have been, what do you call, doing actually. Now here is another interesting kind of a problem. So it says find f where the f of x is e to the x plus 21 plus x power 1 plus x squared power minus 1. Okay. And it is also given that I want that f in which if I substitute 0, I must get minus 2. So you not only have to find f, but you have to find such a f in which if you substitute 0, you're going to get minus 2. So these are called the initial conditions. So these are some additional conditions actually. So this is an initial condition. Okay, this is what that you have to find actually. How are you gonna apply the initial condition? Whenever the initial condition is given to you, then you don't have, so this means that you are not interested in the family of the curve in which you have a general constant, but you want to find a particular constant actually. So if such conditions are given to you, that means you have to find such constants. In other words, you have to find the, so this is the family of the functions. You need to find a member in that family that satisfies this condition. Anyway, so let's do it. So what is f prime of x? It's e to the x plus 20 multiplied by 1 over 1 plus x squared. This is what it is. Now have a guess. What is f of x? So what is the function whose derivative is equal to the e to the x? So what function should I choose whose derivative is e to the x? So this is going to be e to the x plus. What would be the function if I derivate that function? I'm going to get 1 over 1 plus x squared. So if you remember, so 20 would stay same. So the number those which are multiplied, you're going to keep them same. So the derivative, so the function whose derivative is 1 over 1 plus x squared is tangent inverse x. So if you derivate e to the x, you're going to get e to the x. If you derivate tan inverse x, you're going to get 20 times 1 over 1 plus x squared plus what do you call the constant c. So this is really, so you found the function whose antiderivative is this actually. So we have been given initial condition and we need to find what you call such a f in which if you substitute 0, you get minus 2. So let's substitute 0 in the given function and equate it to minus 2. And let's see that what value of c you get. So if you substitute, for example, 0 in your given function, you're going to get e to the 0 plus 20 tan inverse 0 plus constant c. So this is going to be minus 2 equal to e to the 0 is 1 plus 20 times the tan inverse 0. What is the value of the tangent that gives you 0? So the tan inverse of 0, the angle that gives me 0 is 0 actually, plus the constant c. So this means this will become 0, c become 1. So if you take this 1 on the other side, your c will become minus 3. Your c will become minus 3. So hence, the function that you need is function f of x e to the x plus 20 tangent x minus 3. This is what is the function. Okay, that we have to find. Now you can check actually that if you derivate this function, you get this. Okay, and if you substitute say 0 in it, you're going to get e to the 0, 20 tangent inverse 0 minus 3. So this will become 1, this will become 0 minus 3, so you're going to get minus 2. So you see that it gives you what you want. Okay? It gives you what you want. Let's do another example. Interesting example. Now instead of say one derivative, we have been given, for example, two derivatives, second order derivative. So I have been given f double prime of x is given to me. This is 12x squared plus 6x minus 4. And additionally I have been given that f of 0 is 4 and f of 1 is 1 actually. And our task is to find f of x. So find a function whose second order derivative is this and satisfies these conditions actually. Okay. So let's find it. How to find it? Let's compute first order derivative out of this second order derivative. So in other words, what is the function whose derivative is 12x squared actually? So you're going to say, okay, the function whose derivative is, so 12 is going to stay 12, and the antiderivative of x squared is x cubed upon 3, x power n plus 1 upon 3, plus 6, which isn't multiplied, would stay same, and is going to be x squared upon 2, minus 4. So I have what here? So if I have nothing, I can say I have an x power 0 here actually. X power 0, because x power 0 is 1. So 4 would stay same, and what will x power 0 become? So it will become x power 1 over 1 plus a constant c. So if I simplify, my f prime of x is now 4x cubed plus 3x squared minus 4x plus constant c. This is what it is. And to recover f, I need to again antiderivate it. So let's antiderivate it again. So 4 would stay 4, and x cube will become x power 4 by 4 plus x cube will become 3x square, 3x cube upon 3. This 4x will become x square upon 2. There is no x here, so let's assume you have x power 0, so it will become what you call cx plus another constant. Another constant. So now you have a two unknown constant, therefore two conditions are given to you so that you can find these two constants actually. So if you simplify this, okay, so if you simplify this, you're going to get f of x will be x power 4 plus x cube minus 2x squared cx plus dx. And now, so we want a function, so we found the function actually. So the only thing that we want is that this function should satisfy this actually. That if you substitute 0 we get 4, and if you substitute 1 we get 1 actually. So let's say for example substitute 1. So f of 1 is equal to 1, and let's see that what you get from other side. So you get 1 plus 1 minus 2 plus c plus d. Okay. So these two will cancel out. So you get 1 equal to c plus d. Aha, so you don't get a, say for example, one value, but you get an equation actually. You get an equation. So what you need to do next? So now you need to substitute, for example, the other value, which is 0. So if you substitute 0, you're going to get 0 plus 0 minus 0 plus 0 plus d. And this is equal to what you call 4. So what does this shows? This shows that my d is 4. So I have the value of d. So if you have the value of d, now you can substitute this d here and you can get